So, guys, today we will discuss this exercise 13C. The concept of this exercise 13C is this one. If displacement is given, right? Suppose displacement of this. Uh, so, if displacement an object is given by RT equals to F1T and F2T, right? The F1T is the horizontal component and F2 is the vertical component. So velocity we can find out by differentiating displacement. We already know if we differentiate displacement, we get the velocity, and if we um, differentiate velocity, we will get the acceleration, right? This is acceleration. So it means if we will write over here. So what we have to do? Suppose displacement R is given. Suppose displacement is given R. Okay, R is a function of time. Okay, so velocity equals to dr over dt. Velocity v equals to velocity means v equals to, okay, you can use this, and acceleration a will be equals to dv over dt, or you can differentiate displacement twice, meaning is the same. Okay, now in some questions the velocity may be given or acceleration may be given there. So in that case, if you want to go back, so we already know integration, right? Integration or anti-derivative, right? So we suppose we have velocity or we have acceleration, and we want to go back, means we want to get the displacement, so we'll integrate the function. Okay, if we have velocity, we'll integrate velocity and we'll get the value of displacement. Similarly, if we have acceleration, we can integrate once, we'll get the velocity back, and if we integrate twice, we will get the um, um, displacement factor as well. Okay, so so far uh, when you integrate, constant will be there, c will be there, so we can find out the value of c as per the question. We will have to look at the question, and then we will find out the value of constant c. Okay, so we look at this question. Question number one. The position vector of a particle p at a time t is given by r equals to 4t plus 2 3t square minus t, where r is measured in meters and t in seconds. Find the initial displacement of p. So part A, initial displacement. Okay, for initial displacement, t will be 0, right? So you can this rt equals to this one, so you can find out the r0. This is rt, right? r or rt. So r0 equals to, you can see, you will get this 4 times 0 plus 2, 3 times 0 its square minus 0, right? So this becomes 2 and 0, right? So this is the initial displacement. Part B, find the initial velocity. Part B, initial velocity. So velocity we know this one, v equals to dr over dt. So dr over dt means when you need to differentiate this. Okay, you need to differentiate t over dt, 4t plus 2, and then d over dt, 3t square minus t. If you wish, you can do it directly, not an issue. So 4t, so this will be 4 times 1 means 4, this will be 60 minus 1, 60 minus . So now this will be velocity. If we differentiate a displacement, we get the velocity. Now next is so that the acceleration of P is constant and find its magnitude of part C. So acceleration A equals to dv over dt we know. So you will have to differentiate this one. So derivative of 4 equals to 0. This is 6 because of this one is 0, right? So this is the 0. So this is the acceleration, and on that it will be constant because it does not depend on the t time. Okay, so now we have to find its magnitude. So magnitude of A equals to, you can see this one. Well, it will be 6 meter per second square. Okay, so we look at the question 2. A particle moves with a velocity v meter per second given by v equals to 4t minus 1 I plus 5 minus 2 tg. Given the initial displacement of the particle is 2 I minus a from the origin out. So we have velocity. I'm writing velocity as a column vector. So 4t minus 1 and 5 minus 2t. Initial displacement r0 equals to 2 and minus 1, right? So part A we have to find out. We have to find out the displacement r we have to find out. So how can you find out? You integrate velocity, you will get the r. Okay. So it means we have to integrate each term. We have to integrate this 4t minus 1 dt, right? And second is integration of 5 minus 2t dt, right? This, if you wish, you can do it directly, but I'm showing you step by step so that you can understand each and everything. This is 4 times of t2 square or 2 minus t plus c1, and this is 5t minus 2t square over 2 plus c2. I'm taking c1 and c2 because we will have to take two constant, that's why. So this is 2t square minus t plus c1, and this is 5t minus t square plus c2. Okay, so this is the displacement rt equals to, okay, displacement vector, this, right? Now if you see initial displacement vector r0 equals to 2 minus 1. So what I'm doing here, rt equals to this one. So once I know RT, I just look for R0, right? And I have the value of R0 as well. So R0 equals to, this whole will be, C1 and C2, because this rest of the part is having T, so it will be 0, right? And what is the R0? R0 is 2 minus 2 and minus 1 equals to C1 and C2, right? So from this comparison, we can write C1 equals to 2 and C2 equals to minus 1. Okay, so then RT equals to, we can write RT equals to, we can replace C1 and C2 by these values. So this will be 2t square minus t plus 2 and 5t minus t square minus 1. This will be the displacement vector at time t. Okay. Now, after this one, find the distance of particle from O when t equals to 2. So when t equals to 2 means you will find out the R part for part B. You will find out the R2. So this will be, first of all, you find this as a vector, then we can, for distance, we can find out its magnitude. So R2 means this is 2, it's 2 power minus 2 plus 2, and this is 5 times 2 minus 2 is 1. So this is cancel, this is 4, this is 8, and this is 5 to the 10, this is minus 4, I think 5, right? This is out. So when we have to find out distance, so distance means magnitude of 2. So it will be square of 8 plus 5. So this is 64 plus 25. Mm, this is 9. This is 89. Square root 89. Okay. So square root 89 means then you can it will be 9 point something. You can use calculator. It's approximately 9.43 meter. Okay. The process means the very simple. Somewhere we need to find out. We need to use derivative, right? And somewhere we need to use integration. So integration we use when we have to go back. We have to go from acceleration to velocity, velocity to displacement. Then we use the integration. And if we have to go from displacement to velocity, then acceleration, then we use derivative. I hope you would have understood.